Hello everyone, welcome to my channel. I am M.K.JABEEN. Today giving you the knowledge about the execution and tracing of the C program to calculate the sine of any angle using Taylor's series. For the VTU, CBCS, BE, first or second sem, CPL students. First, let us go through the program and then execution and then go for tracing. Okay. First, we define header files here. Trigonometric functions also appear here. So, for that purpose, we have taken the header file math.h. Okay, then standard library.h and standard input output.h for input output functions. Then main part of the program begins here with the open curly braces, then int x. X is the value of the angle we are taking, n is the number of terms in the Taylor series we are using. Okay, I is the index of angle in the this one Taylor series. I will show Taylor series you while tracing. Float rad. Radians means convert the angle into radians, and then result, and the sum of the series resultant series is initialized to 0 here. Okay, then printf statement appears. This line will be printed on the output screen, that is enter degree. Then a scanf function accepts it, then enter the number of terms in the series Taylor series we have to calculate up to. This should we have to enter, and scanf function reads it. Then converting the angle to radians means angle into 3.14 divided by 180. Okay, then for I is equal to 1 to I is lesser than or equal to n, I plus is equal to 2. That is, in Taylor series, index of the x starts from 0 and increment by 2 up to number of equal to number of terms or lesser than number of terms. Applying these conditions we have to take, and if index of the angle index of the x minus 1 modulus 4 is equal to 0, then sum is calculated by this formula, sum plus power of radians to I divided by factorial of I. I will show also how to find the factorial. Okay, if this is not equal to 0 here, then sum is equal to sum minus power of radians to I divided by factorial of I. Okay, then that is we have to take only positive values. Okay, then print the calculated value of the x, that is angle, according to Taylor series and according to library. Okay, here factorial function is here. Factorial of m means for factorial finding the m's factorial, we have to start from I is equal to 1, that is not 0. 0 multiplied by anything is 0. That's why I is we starting finding factorial of a number starting from m, then increment by 1 up to equal to that m number, go on increasing I value up to I is lesser than or equal to that original value which for whose factorial we are calculating, up to that or less than up to that we have to increment i's value, that is f is equal to f star I, then return 1 means return the factorial. Okay, now let us execute once. Give value here 30, angle 30, number of terms 1, value is 0.523333 and 0 by library 0.4997770. Let us trace it and check the value for this same. Here tracing of the finding sin x using Taylor series. Enter the angle. It is 30. We are taking for tracing number of terms 1. Okay. Then we are taking the angle in the form of radians. Okay, to convert the angle into this 30 x value into radians, we multiply x by 3.14 and divide by 180. This is the x value and this is in degrees, that is angle value in degrees. This is the conversion of the angle value into radians. After taking radians, then according to Taylor series, we have to calculate. So Taylor series is like that. Sine of radians is equal to radians to the power of 1. Nothing is there if to the power of 1, then 1 factorial plus, I'm sorry, plus is appeared here first here. Nothing is there means plus here. Then go on alternating giving minus plus like that, and this index increments by 2 here in this Taylor series. Then radians to the power of 3 by 3 factorial. Okay. Here each index value increases by 2. 1 plus 2, 3. And here 5 divided by factorial. Okay, this is the Taylor series. Here plus, here minus, here plus, again here minus, like that it goes on. And the values are incremented from initial value by 2. Okay. 1 plus 2, 3, 3 plus 2, 5, like that. Then radians value we have calculated. Here I is equal to 1. Initial value of I is 1. For one term we are taking no. For that purpose, these terms are neglected here. These terms are neglected. These terms are neglected. The one term we have taken, that is radians divided by 1 factorial. Okay, here I is equal to means index of the power. We have to raise to power radians to 1 in the first term. That is I is equal to 1 here. Okay, the condition is I minus 1 modulus 4. I minus 1 modulus 4 is equal to I minus 1 modulus 4 is equal to 0 here. Okay, 0 modulus 4 is 0. Then answer is 0.523 divided by 1 factorial. Okay, here radians value we have calculated now. That's why this radians value up to the power of 1 means this same value will we get, then 1 factorial, and this is the answer. Then according to library, this is the sign value. So sum is equal to here. This condition value is 0. Condition satisfied. Sum is equal to sum plus the value. That is answer we get. That is sum is equal to is 0. Initialized to 0 in the program. So 0 plus answer is equal to 0. This is the value of 30 in one term of Taylor series. Okay. Then if I minus 1 modulus 4 is not equal to 0, then we have to calculate by giving minus. Okay. Here. Sum minus answer we have to give if condition not satisfied. Okay. This is the result. library sign of 30 is this value. Now let us see the factorial here. Factorial of m integer type number we are calculating here. For that purpose, index of that is initial value of factorial finding starts from 1. Okay, that is elements start from 1 up to equal to or less than the actual value we have taken for finding the factorial. That value I should be incremented by 1, that is f is equal to f star I. Okay, then return one answer. See here, for example, factorial of 3 we are finding here. Factorial of 3 is equal to 1 star 2 star 3. That is initial value is index of first element value is here start from 1. Then increment by 1, this is 2. Increment by 1, this is 3. This condition satisfied now? Here I is equal to 1, I is lesser than or equal to m. Okay, then this value in factorial value is 6 here. Okay, I hope you have understood. Thank you. We got the same values for that as executed by executing the program.